In this video, we are going to evaluate this rational function. We are going to find the integral of this rational function. So I am not going to use partial fractions here. There is a way to solve this one without using partial fractions. I'm going to use the tricks up here and I'll show you why. So here, let's look at the denominator again. So x raised to the power 4 plus 2x squared plus 1. We can see that this one is the same as x squared plus 1 multiplied by itself, x squared plus 1, right? So this one evaluates to, when we FOIL this, that is going to evaluate to x to the power 4 plus 2x squared plus 1. And that is x squared plus 1 multiplied by itself, which is x squared plus 1 squared, right? So this one integral is going to be the integral of x to the third plus 5 at the numerator divided by x squared plus 1, all this one squared dx. And this one, I'm now going to use a tricks up here. And the secret to this one is like using letting x to be equal to the tan of theta, right? Because here tan square theta plus 1 is equal to the secant square of theta. Normally, when we see this, you can easily recognize that we have to use the tangent. So I'm going to let x to be equal to tan of theta and hope for the best. So here the x is going to be secant square of theta d theta because the differential of tangent is secant squared. And now after doing this, I'm going to take our integral from the x world into the theta world. So this is the integral of x is now tan of theta. So that is going to be tan to the third power of theta plus 5 divided by this one is tan to the second power of theta plus 1 all squared d theta. So the x is secant square of theta d theta. That is going to simplify to what? So this is the integral of the tangent to the third power of theta plus 5 divided by tan square theta plus 1 is secant square theta. And this one from the Pythagorean identities. This one is going to be the secant square of theta, but it's already squared. So because it's already squared, that is now going to be secant to the fourth power of theta, right? Because this is secant squared, which is now secant to the fourth power times secant to the second power of theta d theta. So the secant squared will cancel 2 at the bottom. So that is now going to be left with the integral of tan to the third power of theta plus 5 divided by secant square of theta d theta. 2 of this will cancel 2 of that here. Now this one is secant square theta is the same as 1 over cosine square of theta, right? So 1 over cosine square of theta, so that is going to be, or 1 over the secant square of theta is the cosine square of theta. So this one is the integral of the cosine square of theta multiplied by tan to the third power of theta plus 5 d theta. Because 1 over secant squared is the cosine squared. So I is the integral. We can now multiply terms out. So that is going to be the cosine square of theta times the tangent to the third power of theta d theta. This is one integral. Plus 5 is the constant, the integral of the cosine square of theta d theta. So our integral has been split into two integrals. So let's call this one integral 1, this one integral 2, and tackle them one after the other. The first one I'm going to do in yellow, which I always do. So I1 is going to be equal to the integral of the cosine square of theta. And the tangent square cube of theta, I'm going to write that one as a sine to the third power of theta over the cosine to the third power of theta, the theta. And this will cancel 2 at the bottom, leaving 1. That is going to be the integral of sine to the third power of theta. Can write that one as sine to the second power of theta times sine of theta divided by the cosine of theta d theta. I1 is going to be equal to the integral of this one, sine square theta from the Pythagorean identities. That is going to be 1 minus the cosine square of theta multiplied by sine of theta all over the cosine of theta, right? So this one, integral 1 can also be split into two different integrals. So that is going to be the integral of sine of theta over cosine of theta. That is this guy multiplied by 1 and divide by cosine of theta at the denominator minus this one is going to be the integral of sine of theta times cosine square of theta divided by cosine of theta is going to be sine of theta cosine of theta d theta, right? So I1 is going to be equal to what? So the first one is the integral of sine of theta over cosine of theta, which is the integral of tangent of theta. And integrating tangent of theta is just the natural logarithm of the secant of theta. So that is the integral of the tangent of theta. Minus integrating this one, sine theta cosine theta. I am just going to do that here real quick as a rough work. So you can let u to be equal to sine of theta. That is from here. So du is going to be cosine of theta d theta. So in place of cosine of theta d theta, I'm going to replace with du. So that is now the integral of u, which is sine of theta du, which is 1/2 u squared. But what is u? U is sine of theta. So that's going to be 1/2 sine square of theta. So if we integrate this one, we are going to get this. So I'm just going to write that here. That is 1/2 sine square of theta. So this is the integral of the first one, I1, which is this one. Now let's tackle the I2. The I2 is really very easy, which is just 5 times the integral of cosine square of theta. So let's do that in a different color to make things colorful. Why not? So I2 is going to be 5 times the integral of the cosine square of theta d theta, which is 5. The integral cosine square of theta can be written as 1/2 1 plus the cosine of 2 theta d theta. So I2 is 1/2 is a constant, it comes in front, that becomes 5 over 2 in front here. Then we are integrating 1 in the theta world, which is theta, and integrating cosine of 2 theta is integrating sine of cosine of theta, which is sine of 2 theta. And then we differentiate the angle and divide, which is 1 over 2. So this is 5 over 2 times theta, 1/2. Sine of 2 theta can be written as 2 sine of theta cosine of theta. So I2 is going to be what? This one cancels that. And we are going to have 5 over 2 theta plus 5 over 2 sine of theta cosine of theta. And this is the value of the second integral. Now that we have the values of the first and the second, we can just put them together. Sorry for this. This is supposed to be a white pen, right? So the original integral I is going to be I1 plus I2. So I is going to be I1. The value of I1 is the natural log of secant of theta minus 1/2 sine squared theta. Natural log of secant of theta minus 1/2 sine squared theta plus I2. I2 is 5 over 2 theta plus 5 over 2 sine of theta cosine of theta. Our original integral was in terms of x, but our final answer is in terms of theta. So we are not done. We have to move from the theta world into the x world. So this one, we can move back into the x world using this one. X is going to be equal to the tan of theta. That was our initial substitution. So we can draw a right triangle here. We know that our initial substitution was x is equals to tan of theta. X is the same as x over 1. So let's draw a right triangle here with our right angle here. So tan of theta is opposite over adjacent. Opposite. So opposite is here. Our angle is here, theta. So this is opposite to the angle x over adjacent. This line is adjacent to the angle theta. Now we have to find the hypotenuse, the one that is opposite to the right angle. So we can do that by using the Pythagorean theorem. That is the square root of the sum of the squares of the other sides. So x squared plus 1 squared, which is 1. So this is what we have. So now we know that tan of theta is x. So in that case, theta is going to be the tan inverse of x. What about sine of theta? Can we find sine of theta here? Sine of theta is going to be opposite of hypotenuse. Opposite is x, hypotenuse is the square root of x squared plus 1. What about the cosine of theta? Cosine of theta is adjacent over hypotenuse. Adjacent is 1, hypotenuse is the square root of x squared plus 1. So we have tan of theta, sine of theta, and cosine of theta in terms of x. You can just plug that into our integral and take our integral from the x world, from the theta world into the x world. So I is going to be the natural logarithm of the secant of theta. Secant is 1 over cosine, right? We know cosine of theta to be equal to this guy. So in that case, secant of theta is going to be the reciprocal of the cosine of theta. So that is going to be the reciprocal of this, and that is just going to be the square root of x squared plus 1. Cool. Minus 1/2 sine squared theta. This is sine of theta, but there are two of them, so that is going to be x over the square root of x squared plus 1 squared plus 5 over 2 theta. Theta here is tan inverse of x plus 5 over 2 sine of theta times cosine of theta. Sine of theta is x over the square root of x squared plus 1. Cosine of theta is 1 over the square root of x squared plus 1. So I is going to be 1/2. This one is x squared plus 1 raised to the power 1/2, like this. This is the square root, and this one is 1/2 x squared all over x squared plus 1 plus 5 over 2 tan inverse of x plus multiply these guys out. This is going to be x over x squared plus 1. So therefore, after 11 hours of evaluating this integral, our integral, which is x to the third plus 5 divided by x raised to the power 4 plus 2x squared plus 1 dx. This one evaluates to, using the laws of logarithm, this is 1/2 ln of x squared plus 1 minus 1/2 x squared over x squared plus 1 plus 5 over 2 times the arctan of x plus 5 over 2 times x over x squared plus 1 plus the constant of integration. So ladies and gentlemen, this one is the value of our integral. So that is how you solve these kind of integrals. If you have a shorter version of solving this integral, make sure to give a comment in the comment section and let me know what you think. Anyway, this is the answer to our problem. If you find this helpful, make sure to give me a thumbs up and subscribe to my channel for more content. I thank you so much, and I will see you in the next one. Bye bye.